We'll proceed in vector summation calculus. Vector summation and calculus. How I can divide my problem into n different parts and then solve part by part and then sum it. This is what we are talking about. If we are summing up for all the n parts, then what about n tends to infinity? Sometimes we need it. If n is not tends to infinity, then our calculation will be mere an approximation only. It will not be the concrete solution. So n tends to infinity. There are three parts in what we are talking here. First, divide the problem into n different parts. That is the first scenario. Divide the problem into n different parts. If someone divides the problem into n different parts, then solve it part by part. When we solve part by part, when we solve part by part, in each part, okay, I'm sorry, if I divide my problem into n different parts, each part, each part solving will be carried through vector. That is the concept. If I have n different part, one particular part, I would rather say ith part. The ith part calculation would happen through vector. Ith part calculation happens through vector. Once ith part calculation is finished, then we generalize this ith part solution to all n part. We sum it. Means if I have n number of problem, means I have one problem, I divide into n part. Now I have n number of problem. Each part we will solve by vector. Each part, any part, I call it ith part. Sigma means summation. Sigma I equal to 1 to n. And tackling the ith part, solving the ith part. Then sum it for all n. But sometimes the tackling the ith part, how to solve any single part, ith part, we use vector. So vector is used to calculate the ith part. Then we sum it for n. I equal to 1 to n. We sum it for n. Sometimes we feel that summing it to n is not the accurate solution. Summing it to n is not the accurate solution. Then we make n tends to infinity. Okay, where we feel n summing up to n is not the accurate solution. Many times we have described it. Like if I am trying to calculate the circumference of the circle, then the circle I will make part, I will distribute the circumference of the circle into n different parts. First part, second part, third part, fourth part, any ith part, and then into n part. Then I have to calculate the length of the circumference for any part. If I take this as ith part, what is length of the circumference? Certainly I don't know how to calculate the curve length. If I know how to calculate the curve length, then I would have calculated the full circumference in one go only. But I don't know. What I know is calculation of a length of a line segment in a straight line. That I know. If I have a line segment as a straight line, that I know. Okay, but I don't know how to calculate the curve length. So what is straight line? If I talk about any ith section, then this is the beginning and this is the end. If I draw a straight line from these 2 points, if I take any 2 points and draw a straight line connecting these 2 points, if I if I take any ith section, if I take any I if I take any ith section, I divide it into n section. If I take any ith section, this point and this point, if I connect like through a straight line, if I connect through a straight line these 2 points, then there will be a straight line like this. What is the length of this line? If I know the length, then I'll arrange because same length will be for other section also, because circular we have taken the same circumference in n section. Summation I equal to 1 to n length of ith section. What is length of ith section? If this point is x1, y1, this point is x2, y2, it is x2 minus x1 whole square plus y2 minus y1 whole square root. This gives me a clue to use vector. Because if I say that if I have 2 points here, this point and this point, I have 2 points here. If I connect these 2 points through a line, I can represent this line through vector x2 minus x1I plus y2 minus y1j. This is a vector. Okay, then I would rather say this is a vector. Then I would rather say summation I equal to 1 to n length of a vector, delta p. What is delta p? If this point is p1 and this point is p2, if this is p1 from center, it goes like this. If it is p2 from center, it goes like this. These are called position vector. This is position vector, this is position vector. This is p1, this is p2. This point is p1, this point is p2. This is P1 and this is P2. These are the 2 points. Okay, if these are the 2 points, then there is a line connecting these 2 points. One is P1 and one it is P2. P1, P2. P1 minus P2 is delta P. P1 minus P2 is delta P. Delta P means this is P1, this is P2, then P1 minus P2 will be a vector that will connect. Hope, confusing. I have divided this circumference into n part. Okay, then I have taken any ith section. There are n sections. I have taken any ith section. If I have taken any ith section, then this point of the ith section is P1. This point ith section is P2. If I connect through a straight line, this will be the length of this section. If I connect this P1 to origin, this is called position vector P1. If I connect point P2 to origin, this is P2. P2 minus P1 vector will be this vector. This is what we want. Okay, I can write this vector. If this point is P1 and this point is P2, if this is x1 comma y1, this is x2 comma y2, what is the vector representation of these two? X2 minus x1I plus y2 minus y1j. Makes sense. Someone can break it. It will be x2I plus y2j minus x1I plus y1j. x2I plus y1j is P2. x1I plus y1j is P1. P2 minus P1 is this vector. Makes sense? Okay. If P2 minus P1 is this vector, magnitude of this. So I can call it delta Pi. Since this is ith section and P2 minus P, I can say delta P. Summation I equal to 1 to n and the magnitude of delta Pi, it will give the full circumference. But someone would say this is not accurate. You have taken all straight lines. You have taken all straight lines. Okay, you have to take curved line into calculation. Then how I can calculate curved line when I don't know? Then what I will do, I'll make this division of the circumference that I made n division. I'll make n tends to infinity. Infinity. If it is infinity, then one section, subsection what we are taking, its length will be 0, tends to 0. Then this curved line and a straight line will be of same length. This curved line behave like a straight line only. Then it will come as accurate. Summation I equal to 1 to n, n tends to infinity, and then magnitude of delta Pi it will give. So here we need n tends to infinity. Where we need n tends to infinity? Here we need n tends to infinity. Anyway, we are proceeding discussion in parameterization. If I have a circle, in xy plane, and then we are talking about a shifted circle. Okay, this is called circle that is centered at the origin. If this is the circle, this is origin. And x-axis and y-axis, this is a circle, it is centered at the origin. If this circle is centered at the origin, what is the equation of the circle in xy plane? X square plus y square equal to a square. A is the radius, equal to a square. What about equation of this circle? Now this circle, consider, this is the circle. Now consider this circle, I shift up. Now circle is going up. Now this is the circle. Earlier circle was here. Now circle is going up here. Okay, if circle is going here, then what is the equation of the circle? If circle is shifting, then how much it is shifting? It is shifting a by 2. How it is shifting a? If this is the radius a, then circle is shifting by a and it is going in y direction. What is the equation of circle? What is the equation of circle? Equation of the circle is x square plus y square. Y will become y minus a because it shifted in along y direction. Whenever there is a shifting along positive y direction, we have to subtract by that much amount x square plus in bracket y minus a whole square equal to a square. Okay, that is the new equation of circle. If someone say, I have another parameterization. Parameterization means can I represent our formula x square plus y minus a whole square equal to a square. This formula through third independent component, not in x, y. Through an independent component that is not lying on x and y. Then we are bringing a concept of r and theta. R and theta is the component that does not lie on xy plane. That is separate. R theta is separate. What is relationship? X equal to r cos theta or x equal to a cos theta if radius is constant. If I have a center, if I have a circle centered at the origin, if this is the origin, and circle is centered at the origin, then if I talk about radius and theta, then radius will behave like some entity that moves like this. Y-axis moves like this, x-axis move like this, but radius is an axis. Radius is an axis, but it moves like this. Its orientation is like this, and when it is moving, then it is changing the angle with the x-axis. Actually, angle is moving. Okay, radius is not moving. In a way, radius is not changing. If I keep radius constant and make radius move, means angle is changing and radius is constant. If it is going like this, then it forms a circle. Circle centered at the origin. When radius is not changing. But if circle is not centered at the origin, circle is like this. This is also a circle. Okay, where origin is here, 0 comma 0, origin is here, center of the circle is here. If I talk in the movement of radius, then radius will move like this. When angle is 0, radius is 0. When angle is moving like this, then radius is growing. Radius is moving and radius is growing. When angle is 90 degree, radius is maximum. When angle is growing, radius is shrinking. When angle is 0, radius is 0. Okay, if I have this kind of relationship, then someone can place in the equation. What is the equation? X square plus y minus a whole square equal to a square. Y equal to a sine theta. X equal to a cos theta. If someone places it, it will come as a square equal to a sine theta. A equal to sine theta or r equal to sine theta if I take radius as variable. Means r equal to sine theta is a circle. R is not constant, R is varying with the theta. R equal to sine theta is a circle which makes R equal to sine theta is a circle. This is R equal this this is origin, and if center of the circle coincide with the origin, the equation of the circle in terms of R and cos theta is R equal to A. R is fixed, R is not changing. R is fixed, R is fixed. R equal to A. Radius is always A. Theta is going 0 to 2 pi. But if origin is here, then radius is moving like this. Radius is growing with the theta. Then R equal to sine theta. Then angle theta. When theta is changing, radius is also changing. When theta is coming to pi, so this circle theta is going 0 to pi, not 0 to 2 pi. And r is going from 0 to r is varying as sine theta. When theta is 0, r is 0. When theta is 90 degree, r is 1. What about maximum radius as 1? Then r equal to a sine theta. R equal to a sine theta. When theta is 90 degree, radius is a. Otherwise, radius keeps changing. What is the circumference of the circle that we are talking about? For this, we have already taken What is the actual problem? Actual problem is that I have a circle. I have a circle which has a center at 0 comma a. Center at 0 comma a. That is the circle. Now tell me the circumference of the circle. Then I did parameterization. Parameterization in a way that x equal to r cos theta, y equal to r sin theta. Now we are leaving x and y concept and we are putting load on r and theta. Secondary coordinate. Okay, in that fashion, if we draw x equal to r cos theta, y equal to r sin theta, x square plus y square equal to r square, means every moment x square plus, if this is x and this is y, if this is x and this is y, any point I take on the circle, then x square plus y square equal to r square as per the fundamental. X equal to r cos theta, y equal to r sin theta. In that fashion, x square plus y square equal to r square. It is constant. Okay, but someone will say, "Well, how you can say it is constant? It is not constant. How you say it is not constant? Okay, see here. X is 0, y is 0. X square plus y square equal to r square. Okay, I'm sorry. So I'll rephrase this. X equal to r cos theta, y equal to r sin theta. X square plus y square equal to r square. If x square plus y square equal to r square, means at any point x comma y, any point x comma y, if I take, it will be equal to r square, where r may be constant. If r is constant, then this is the circle. If r is not constant, then this is the circle. Okay, r is variable, so x square plus y square will vary at every point according to r square. Tan y by x equal to tan theta, theta equal to tan inverse y by x. Now it giving a hint that there is another coordinate system called theta and r. There is another coordinate system theta and r, like xy. This is theta r coordinate system. This is xy coordinate system. This is xy coordinate system. This is theta r coordinate system. This is something that we are delegating our problem. We are delegating our problem to any third party. Means the control of calculation will be in the third party, not in xy plane. I want to calculate the circumference of a circle x square plus y minus a whole square equal to a square. X square plus y minus a whole square equal to a square. Okay, if this is the circle x square plus y minus a whole square equal to a square, if this is the circle, I want circumference of this circle. To calculate the circumference of this circle, now I will take third part, secondary coordinate system. This is purely in the Cartesian coordinate system what we are trying to calculate. Rather than solving into Cartesian coordinate system, I am trying to solve in through the theta r plane. This is solving through parameterization. I parameterize it x equal to r cos theta, y equal to r sin theta. If I have any point here at xi plus yj, that will be rewritten as x r cos theta I plus r sin theta j. R cos theta I plus r sin theta j. This is how it will be written any point here. If this is there is a position vector like this, if there is a position vector like this, and this point is xi plus yj, it will be r cos theta I plus r sin theta j. You said r equal to sin theta, yeah, then someone can place it. Sin theta cos theta I plus sin square theta j. That will, now we have another vector. Any point if I take along the circle, or if I have a position vector like cos theta sin theta I plus sin square theta j, if I have a position vector like this, which is changing with theta, I believe it is very much alright. See how I change xi plus yj, xi plus yj change into a vector called r vector. R vector. R is a function over theta. Earlier I have a vector called xy vector, xi plus yj in Cartesian coordinate system. Can I control this vector xi plus yj through single independent variable, that is theta? Yeah, it's possible. That is called parametric vector. Parametric vector is written as r, on top of it a vector sign. R on top of it vector sign. Someone can place a bracket and write theta inside it. r function over theta. This is the parametric vector. It should vary only with the theta. In that sense, it is cos theta sine theta I vector plus sine square theta j vector. Now, same thing, circle is varying through theta only. Now, concept is can we use? Now, we are changing our problem into parametric vector. Now, I have a theta r plane. I have a theta r plane. I have a theta r plane. This is theta and this is r. If I have a theta r plane, then what is the equation of the circle here? R equal to sine theta. This is r equal to sine theta. This, this is r equal to sine theta. This is r equal to sine theta. This is r equal to sine theta. This is the curve in theta r plane. Okay, what I am trying to calculate? I am trying to calculate this curve length, that is sine theta, and mapping of this curve length into xy plane. What is curve length as sine theta? Can someone estimate like what would be the curve length if this is theta and this is r? What is curve length along the sine theta? From 0 to pi, this is 0 and this is pi, this is 90 degree. What is the length of this curve in theta r plane? Okay, in theta r plane, if I try to calculate the length of this curve, we are talking about length vector, a vector that represent a curve line. What is any vector here? So there should be third one. If I take any point here, if I connect origin, that will be position vector. What is this point? This is r comma theta or theta comma r. This point is theta comma r. If I connect through the origin, this is called vector. If I connect through origin, this is origin and this is point. This is origin and this is the point. If this is the point, then I connect like this. This point is theta comma r. This is origin, this is point theta comma r. If I connect like this line is going through the theta comma r. What is the position vector? Theta unit vector plus r unit vector. Makes sense? Theta unit vector plus r unit vector, because this is theta axis, this is r axis. Now, if I want the, okay, this is the position vector. If I want curve vector, means a vector that will go along the curve, not like this. This is position vector. This is not the curve vector. This is curve vector. If I want to represent any curve through vector, many times we have talked that there is something called length vector. If consider this was not a sinusoidal line, this was a straight line. Consider this is theta axis and this is r axis. There is a point here r comma theta. If this is a straight line connecting origin and origin, okay, so this point is origin, and this point is theta comma r. I have taken this is theta and this is r. This is origin and there is a point called theta comma r. If I connect this through the straight line, this is origin and this is theta comma r. It passes like this. Okay, then what is the vector representation of this line? Theta unit vector plus r unit vector. If this point was x comma y and this is origin, that was xi plus yj. If point is theta comma r and this is origin, then the vector representation of this straight line is theta unit vector plus r unit vector. Now we do not have a straight line. Instead, this is a curve line. How to represent this curve line through the vector? If this point is theta comma r, if I draw a straight line, then this will be the straight line connecting. This is not what we want. We want a vector that will go along the curve. For a curve line, if I talk in curve line, then curve has everywhere r by theta variable. If it is a straight line, if it is a straight line, then everywhere r by theta is constant. If it is a curve line, then everywhere r by theta is variable. In that sense, I have to if I am able to represent our vector with r by theta, then it will represent the curve line. Because anything, if I want to represent it mathematically, then I must address the independent component. I must address the variable component. And here variable is theta by, variable is r by theta. Means if I have a vector, theta, theta unit vector plus r, r unit vector, I have to represent this in r by theta. Take out theta from here, it will become theta unit vector plus r by theta, r unit vector bracket close into theta. Change division into differentiation and multiplication into integral calculus. This is called length vector, the vector that varies with the curve. R, sorry, theta unit vector plus dr by d theta, r unit vector, bracket close into theta into d theta. This is the, what is length of this sinusoidal curve? What is length of this sinusoidal curve? Length of this sinusoidal curve is the length of this length vector. If I have a vector representation, if I calculate the magnitude of the vector, I get the length. Very simple. If any point is any vector that is 2i plus 3j, means it is connecting a point origin 0, 0 to point 2, 3. What is length of this vector? 2 square plus 3 square root. If I have a vector that is theta unit vector plus dr by d theta r unit vector bracket close d theta. If I have a vector like this, if I calculate the magnitude, it will give the length of this vector. Okay, that we will see. This gives the length of this vector. What it will be? What it will be? It will be, what is magnitude of this vector? Theta unit vector plus dr by d theta r unit vector d theta. If I see, there are two parts here, one is vector part and one is differential part. So magnitude, if I calculate, it will, I have to calculate for the vector part. It will be 1 square plus dr by d theta whole square, square root into d theta. Okay, into d theta. Dr by d theta, if r is a function of theta the way we have now, r is sine theta, dr by d theta will be cos theta, 1 plus cos square theta whole square d theta. If I integrate with theta 0 to pi, it will give the length of the sinusoidal wave. Make sense? Let's watch it closely. What we are doing here. What is our length vector? Length vector is I plus dr by d theta. Sorry, theta unit vector plus dr by d theta r unit vector. Bracket close into d theta. If I break it, it will become d theta, theta unit vector plus dr r unit vector. Is it not, is it not the is it not the derivative of any position vector? What is position vector? If this is origin and this is point theta comma r, if this is origin, this point is theta comma r, then this is position vector. If this is any point p, then this is position vector. Theta unit vector plus r unit vector is position vector. dp by d theta is d theta unit vector plus, I'm sorry, I'll rephrase this. If this point is p and this point is theta comma r, this is theta plane and this is r. Theta axis, this is r axis. I have any point p here, any point p here. Okay, then what is position vector? Theta unit vector plus r unit vector. This is in synergy with xi plus yj as a vector. Okay, if that is the case, then what is the differential of p, derivative of p, d of p, with theta or with r, that I am not saying. Just d of p. What is derivative of this? Derivative of this, that will be d theta plus d theta theta unit vector plus dp dr r unit vector. I don't understand, what are you saying? What are you saying? Okay, I am saying there is a point here, there is a point here, there is a point here called P, and this is origin. I am connecting this point. P is theta comma r. This is theta and this is r. What is the position vector? Theta unit vector plus r unit vector. What if I say position vector is capital P on top of it and arrow mark? What is d of position vector? Just d of position. Differential of the position vector. No, but I don't know what is d. I know d by d theta. I know d by dr. Okay, you tell me d of d theta only. That will be solace for you. Okay, but I want, what is d of d theta? What is dp by d theta? If I calculate dp by d theta, then it will dp by d theta, it will come as d theta by d theta theta unit vector plus dr by d theta r unit vector. It will come as theta unit vector plus dr by d theta r unit vector. This is what it will come. I want, but you said you want d of p, not d of p by d theta. Yes, d of p is same as d of p by d theta into d theta. Same thing. So you wanted dp, right? Yeah, dp is dp by d theta into d theta. dp by d theta is d theta unit vector plus dr by d theta r unit vector outside d theta. If you break it, it becomes d theta theta unit vector plus d r unit vector. More or less what I am trying to say is the length vector what we had calculated, that was d, that was theta unit vector plus dr by d theta r unit vector bracket close into d theta. That is same as dp by d theta into d theta. That is same as dp, means differential of any position vector is the length vector. Make sense? What is your actual problem? Actual problem is we are trying to calculate area, circumference of a circle in xy plane. This is the circle. Circumference of a circle in xy plane. Equation of the circle is, it is centered here. This is the original problem. Equation of the circle is x square plus y minus a whole square equal to a square. That is the equation of the circle. If I make, okay, if I make a as 1 by 2, that is the radius, okay, then it will be x square plus y minus 1 by 2 whole square equal to 1 by 2 whole square whatsoever. This is the circle for which I want the circumference. If you want circumference of this circle, this is xy plane. I take here theta r plane. The if I have a relationship x equal to r cos theta, y equal to r sin theta, then I have, if I have relationship x equal to r cos theta, y equal to r sin theta, then in that fashion in theta r plane, I have a sinusoidal relationship. This is sine wave. Okay, r equal to sin theta, x equal to r cos theta, y equal to r sin theta, x square plus y minus a whole square equal to a square. If someone place it here, it will become r equal to a sin theta, r equal to a sin theta. If I take a as 1, hope it will come as, we'll try, x square plus y minus a whole square equal to a square, x equal to r cos theta, r square cos square theta, r square cos square theta plus y minus a whole square, y square plus a square minus 2ay. Okay, y square will be r square sine square theta. Together it will become r square. Now we have a square. Outside also we have a square. A square cut down. We have minus 2a minus 2a y minus 2a r sine theta. Now it becomes r square equal to 2a 2a r sine theta. R and r gone. Now we have r equal to 2a sine theta. That is the equation, not a sine theta, the way we are thinking. R equal to 2a sine theta. That is the equation of the circle. R equal to, consider a equal to 1 by 2. R equal to 2a sine theta is the equation of circle, which forms circle like this. Consider a equal to 1 by 2. Then r equal to sine theta. Okay, in r theta plane, it will be sine theta. We are trying to calculate circumference in xy circle. If I want circumference in xy circle, then I will chop this theta, that is 0 to pi, into n part. If I chop into n part, what will be the what will be the length of this section for the ith part? I chop in theta r plane. This is theta. This is r. I chop in theta r plane this section 0 to pi into n part. I chop it into n part. If I chop it into n part, consider this is ith part. If this is ith part, then ith part will go up and it will hit here. This is the circumference of this line. This is the length of this line. If I talk accordingly in theta or plane, we have talked yesterday also. If I talk in theta or plane, same thing. Then this is the circle. I'm in XY plane. This this is the circle. Hope. This is the circle. Now, what is theta here? Theta is if I move a radius, theta is going 0 to pi, 180 degree. If I chop this angle into n part, then this is the first part. Then this is the first part, this is the second part, this is the any ith part, and then this is the nth part. This is the ith part. If this is the ith part, then this ith part, this angle correspond to theta in theta or plane. If this is theta, 0 to 2 pi. If this is 0 to, I'm sorry, 0 to pi, r equal to sine theta in theta r plane. I cut 0 to pi into n section. This is the ith section. If I go up and match the sinusoidal wave, that is the length of the section. If I talk in xy plane, this is the ith section. This is angle theta. Delta theta I. This is delta theta I. The way we had delta theta I there, means there delta theta I had a width of pi by n. This angle is also pi by n. Okay, in that case, what is the length of this vector? If I talk about length of this section, then length of, if I represent this section through vector, then length of this vector. What is this vector? What is this point? If I talk in polar coordinate system inside Cartesian coordinate system, this is the radius when radius is moving in angular fashion. This is polar coordinate system inside Cartesian coordinate system. There, any point is represented as theta r comma r. Theta r is the arc length. Any point, if I say here, that is x comma y. If I talk about any point here in Cartesian coordinate system, this is x comma y. This is x comma y. Okay, if I talk in polar coordinate system, this is theta comma r. But theta is angle and r is the radius. So theta comma r, it will not work in the Cartesian coordinate system. Because theta is angular, it has to be in displacement. If it is in displacement, then this point is theta r. If this is r and this is theta r comma r. What is the vector in polar coordinate system? Theta unit vector plus r unit vector. What will be displacement? What will be the length vector here? Okay, take out theta because we are making theta vary. R is also component of theta only. Theta is main independent component. If I take out theta from here, it will become r theta by theta unit vector plus r by theta, r unit vector, bracket close into theta. If I convert into calculus, it will become r d theta by d theta, means r theta unit vector plus dr by d theta, r unit vector, bracket close d theta. What we have learned from the previous section, this is theta, this is r, this is sinusoidal. This is sinusoidal. What we learned here, if I want length vector, if this is sinusoidal, if there is any point here theta comma r, this is called position vector. If I take like this is called length vector along the line. Length vector is differentiation of position vector. Derivative of position dp, derivative of p is the length vector. If I see here also, it is r theta unit vector plus dr by d theta, r unit vector, bracket close into the d theta. If someone breaks it, it becomes r d theta, theta unit vector plus dr, r unit vector. This is exact differentiable to position vector. What are you trying to say? What I am trying to say is length vector of a polar coordinate that is superimposed on xy Cartesian coordinate system is r theta unit vector plus dr by d theta, r unit vector into d theta, into d theta. This is what the length vector. What is r theta unit vector plus dr by d theta, r unit vector? If I watch it closely, It is d or dp by d theta, the way we did there also. What is the length vector? Length vector in polar coordinate system is dp is length vector in polar coordinate system is differentiable of the position vector dp or dp by d theta into d theta. Same thing we are getting. If I have a vector representation of the polar coordinate system inside Cartesian coordinate system as r theta, theta unit vector plus r unit vector, I have to take out one independent component to convert it into length vector. I am taking out theta. It becomes r theta unit vector plus r by theta. I'm dividing it by theta. R theta unit vector plus r by theta r unit vector bracket close into theta. If I convert into calculus, it will become r unit vector plus sorry r theta unit vector plus dr by d theta r unit vector bracket close into theta into d theta. The first part, if I see closely, it is exact differentiable of position vector. What is your position vector? Position vector is r theta theta unit vector plus r unit vector dp by d theta. P is position vector, that is r theta unit vector r theta theta unit vector plus r unit vector. This is position vector of the polar coordinate system inside Cartesian coordinate system. If I do dp by d theta, if I do dp by d theta, then it will become r theta unit vector plus dr by d theta r unit vector. Okay, hope. I'll rephrase it again. What is length vector we have computed for the polar coordinate system inside Cartesian coordinate system? That is r theta unit vector plus dr by d theta r unit vector. Bracket close into theta. Bracket close into theta. Okay, or r theta unit vector plus dr by d theta r unit vector bracket close into d theta. This is the length vector we have computed. This vector will go all along the curve r theta unit vector plus dr by d theta r unit vector bracket close into d theta. If someone is watching it, the first part, that is the vector part, is exactly, if I say put p is r theta comma r or r theta theta unit vector plus r unit vector, if this is the position vector, then first part of the length vector is dp by d theta. dp by d theta. P is r theta unit vector plus r unit vector. dp by d theta is r theta unit vector plus dr by d theta theta unit vector. Actually, length vector what we are describing of the polar coordinate system in the Cartesian coordinate system is dp by d theta into d theta. Same thing in everywhere. Means if I have a position vector p, I do dp by d theta into d theta. This is d of p, that is the length vector. Now can I go for hybrid model? This is where I am trying to put emphasis, is that if I take length vector, if I try to calculate the ith section length, if I cut angle into n part, this is the ith section length, this is the ith section, delta theta I. What about this arc? This arc I'll represent through length vector. What is this length vector? That is r theta unit vector plus dr by d theta r unit vector bracket close into d theta. Your first part is vector. Yes, first part is vector. What it is? R theta unit vector plus dr by d theta r unit vector. Okay, what is your position vector in of polar coordinate system? That is r theta unit vector plus r unit vector. Because any point in polar coordinate system is represented as theta r comma r. Means you are trying to say your length vector is more or less dp by d theta. P is r theta unit vector plus r unit vector. Then your length vector is r theta unit vector plus dr by d theta r unit vector. That is nothing but dp by d theta only. If p is theta r theta unit vector plus r unit vector. Yes, dp by d theta, you are right, into d theta. This is what we are saying. Then this is p. P can be anything, right? If it is a position vector, it can be anything. Yeah, it can be anything. If this is p, then it can be xi plus yj also. Yeah, it can be. Then it can be d of xi plus yj by d theta into d theta. How you can say like that? One is xy, one is d theta. But as per the mathematics, it is how it is. You are saying your length vector is r theta unit vector plus dr by d theta r unit vector. Yeah, bracket close into d theta. This is the length vector. First part is vector. What is your position vector? Position vector is r theta theta unit vector plus r unit. But then it is dp by d theta. Yeah, it is dp by d theta. Then p is position vector. P position vector can be anything. If you represent in polar coordinate system, then it is r theta theta unit vector plus r unit vector. But p can be in Cartesian coordinate system also. After all, you are solving a problem in Cartesian coordinate. Yeah, then it can be d of xi plus yj by d theta. D of xi plus yj, because any position vector in Cartesian, any point in Cartesian coordinate system, position vector can be represented as x comma y. Same in polar coordinate system, it can be represented as theta r comma r. Same in theta r plane, it can be represented as theta comma r. In xy coordinate system, it can be represented as theta r comma r. Okay, it is little different. But you said whatever you said your length vector it is dp by p can be anything. If you are talking in Cartesian coordinate system, p can be anything. Yeah, p can be anything. Then it can be d of xi plus yj by d theta into d theta. Yeah. Okay. How we proceed? Now we have xi plus yj by d theta. X equal to r cos theta. That is the relationship. Y equal to r sin theta. Yeah, that is the relationship. Then proceed. How we proceed? Proceed. D of r cos theta I plus r sin theta j by d theta into d theta, where r is variable of sign, r is varying with the theta. What it will become? D of r cos theta by d theta I vector plus d of r sin theta by d theta j vector into d theta. Calculate. Okay. What is? Let's proceed now. D of r cos theta by d theta I vector plus d of r sin theta by d theta j vector. Bracket close d theta. If I differentiate first, it will become r d sin theta by d theta plus d cos theta by d theta plus cos theta dr by d theta I vector plus now we have r d sin theta by d theta plus sin theta dr by d theta j vector. What is d sin theta by d theta? If I change it d theta as delta theta, d theta as delta theta, and r as delta r, then first becomes r d sin theta or delta sin theta by delta theta plus plus I'm sorry r d cos theta, r delta cos theta by delta theta plus cos theta delta r by delta theta full I vector plus now we have r delta sin theta by delta theta plus sin theta delta r by delta theta j vector. What is delta theta delta r? For the ith section, we have this as delta theta. And when r is changing like this. It is lower here and higher here if I go up, or it is like this. If I change r1 to r2, when I have a circle like this, then r is changing from here. R is changing from here. Okay, if r is changing from here like this, then if I talk about the ith section, the r is small and it is growing. If this is ith section, this is delta r of the ith section. R2 minus r1 is delta r of the ith section. This angle is delta theta. Delta ri, delta theta I. Now this whatever we are saying dp by d theta, it becomes like r. Consider any r. This r delta cos theta by delta theta I. What is cos theta? This is cos theta. This is theta. This is theta delta theta I. Make sense? Okay. R d of delta of cos theta. Delta of cos theta by delta theta plus cos theta delta r by delta theta, or delta ri by delta theta I. Delta r is this minus this, or this minus this. This is delta theta I vector plus r delta sin theta by delta theta plus sin theta delta r by delta theta j vector. Okay, full in bracket delta theta I. This is the length vector of the ith section, sum I equal to 1 to n, where n tends to infinity. Will it give the length of the full curve, right? Okay, summation I equal to 1 to n, n tends to infinity. And then dp by d theta, or dp means delta p. dp means delta p, change in position vector. This is delta p. If this is the circle, this is the one ith section. If this is the ith section, if this is P1, this is P2, then this is delta P. We have talked about it. Delta Pi, ith section delta P by delta theta I into delta theta I. We can break in that fashion also. Or dP by d theta. P is xi plus yj, x equal to r cos theta plus r cos theta I plus r sin theta j, d of d theta. Then break it into differential and change delta d theta to delta theta, dr to delta r, and make the expression. That expression into delta theta I d theta at the end, dp by d theta into d theta. This whole will give the circumference of the circle. Someone can try. I believe we have crossed the time. Okay, probably we'll try doing it, and we will do many other things also. This is parameterization of solving any problem through parameterization vector. What we are doing in theta or plane, same thing we are trying to achieve in the xy plane. Okay, through vector. Vector can be hybrid vector. One is p and one is theta. P is in xy and theta is in. Someone can believe this, which will give a circumference. Someone can try. Please don't mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone.